Okay, now let's see here, Ashwin. Uh, think as a scientist, okay? Apart from force, does the acceleration depends on any other factor? What's your opinion?
Yes, it like the frictional force
Mm-hmm.
also
Good.
can affect the acceleration motion as
Yes.
well. Um, uh, like
Mm-hmm.
it's also like the
Mm-hmm.
weight of an object, how the mass, like how much it weighs. Because like
Mm-hmm.
if the same amount of force
Mm-hmm.
is able to push a small object like this much, the same
Okay.
amount of force cannot push like a bigger object the same distance.
Hmm. Yes, good. So let's see here. It said that ki from everyday experiences, you know that with the same magnitude of force, it is easier to set lighter objects in motion, right? Than heavier ones. This led to a second hypothesis that for the same force, a smaller mass has a larger acceleration or a larger mass has a smaller acceleration, right? Do you know it now? So now how can you test your second hypothesis? So now we will test this hypothesis, okay, by an experiment or demonstration activity. So this activity is recommended to be performed as a classroom group activity facilitated by the teacher, okay. So here we have to repeat the activity, same activity 6.3 with a variation. Keep the mass of the cup and objects instant it constant, okay. Double the mass of the cart by adding more objects on it. Is it clear now? Now measure the mass of the cart with the object inside it with a weighting scale. Carry out steps 5 or 6 of the activity 6.3, okay. So using the values of the time measured, find the ratio of the acceleration. Here we have to find the ratio of the acceleration for these two cases, okay. The first one in which it has less mass and the second it has more mass, okay. So do you find that for the same force, when you increase the mass of the cart, the acceleration decreases, right? It will happen, right? We also observe these things in our day-to-day life. This means that for a given magnitude of a force, the acceleration produces is inversely related to the mass of the object, right? The relation between the force, mass, and acceleration is expressed in Newton's second law. Okay, so one of the most fundamental ideas of all in all of science, Newton's second law motion can be started as कि when a net force acts on an object, the object accelerates in the direction of the net force. Okay, so please give the heading Newton's second law of motion and write this one. After that, the magnitude of the acceleration is proportional to the magnitude of the net force and is inversely proportional to the mass of the object. Okay, is it clear? So please note down first on this. After this, we will see the mathematical formula for this statement. Okay, is there any doubt in this statement?
How should I say like the second law of motion is like the object
Yeah.
moves in the direction of the net force.
First give the heading Newton's second law of motion, okay? And under it write the statement, okay? When a net force act on an object, the object accelerates in the direction of the net force. After that, the magnitude of the acceleration is proportional to the magnitude of the net force and is inversely proportional to the mass of the object. Please note down this one. So done. Is there any doubt?
No.
Okay, now we will see the mathematical formula or representation for this statement. As here it said, ki magnitude of acceleration, right, is proportional to the
Mm-hmm.
magnitude of the force. So what we can write in this way? M will be directly proportional to the F and inversely proportional to the mass of the objects. It's mean we can say that it will be equal to 1 by M, right? Is it clear now?
Yeah.
So here we can say that, see the mathematical representation, as acceleration is directly proportional to F and acceleration is inversely proportional to 1 by M, right? So we can say that ki acceleration will be
Yeah.
F by M, right? Is it clear or any doubt? So here we can say that ki this formula will become force is equal to mass into acceleration, right? Or acceleration is equal to mass, acceleration into mass, right? Is it clear? Where A denotes the acceleration and F denotes the
Yeah.
force and M denotes the mass of the object. The direction of the acceleration is the same as the direction of the net force. Okay, is it clear? So please note down this mathematical representation and write this point also. Okay, is it clear?
Yeah.
Yeah, please do it, dear.
No.
Okay. So let's see here. As it say, you know that SI unit of mass and acceleration are kg and meter per second square, right? So
Yeah.
for mass 1 kg and acceleration of 1 mass meter per second square, then using this equation, the above one, we obtained कि force will be the magnitude of the sorry SI unit of force will be here. It become F is equal to mass into acceleration, right? Mass is kg and acceleration is meter per second square, right? Is it clear? So it will be kg meter per second square,
Yeah.
or you can just say that Newton, 1 Newton. Okay. So 1 Newton of the force is defined as the force that produce an acceleration of 1 meter per second square and an object of the mass 1 kg. Okay. Is it clear
Yeah.
or any doubt? So please note down first of all this one.
No. No.
Okay. And then this one. These are the important points. Okay. So is there any doubt?
No.
Okay. Now let's see here. You know that under the influences of gravitational force, an object fall towards the earth, right? So during the motion, the acceleration involved is called the acceleration due to the gravitational force by the earth. Okay. And it is denoted by Z.
Yeah.
So you can give the heading acceleration due to the gravitational force by the earth, and under it you can write during or you can directly write कि under the influences of gravitational force an object fall towards the earth. Okay, so during the motion, this motion, the acceleration involves is called acceleration due to the gravitational force by the earth. Okay, suppose a object is falling from a certain height, then the acceleration which act on it, that acceleration is known as the acceleration due to gravitational force. Okay, and it will be denoted by the small g. Okay, so it unit is the same, its unit will be same as that of the acceleration, that is meter per second square. So using the equation 6.2, the above one, the gravitational force acting on an object mass m will become F equal to mg. Okay, this will happen when a force, when a acceleration due to gravitational force act on it. Okay, it's mean the object is falling from a certain height. Okay, is it clear?
Mm-hmm. Yeah.
Okay, now. Now the value of the acceleration due to gravitational force by the earth is, that is the value of the g is 9.8 meter per second square. Okay, this gravitational force act on the object, okay, when it falls from a certain height. So you have to note down all these points, okay. Now it can be taken to be nearly constant near to the surface of the earth. So for quick estimations we can take the z is equal to 10 meter per second square, okay. So please note down all these points. After this we will continue the next part, okay. Please
Okay.
note down. So is there any doubt?
No.
No. Now let's see here. There are some points are given. Traits of curiosity. Okay. How much does a force of 1 Newton feel? Okay. If you hold 100-gram mass in your palm, the upward force your palm applies on the mass is around 1 Newton. So can you calculate it? How much does a force of 1 Newton feel?
Like,
Or hello?
where's the, so, can you show this question? What is it?
What?
Uh, can you show me where the question is on the page so I can see?
Here this one.
I didn't hear you properly.
Here, this one. How much does a force of 1 Newton feel if you hold 100-gram mass in your palm? Okay, the upward force your palm applies on the mass is around 1 Newton. Okay, so this one you have to do as a homework, and let's try it. You can do this one or not? Okay, I think you can do it, right? Okay.
Yeah. So, yeah.
And here the next note is the acceleration due to gravitational force by the earth g does not depend on the mass of the object. This is the very important point. Please note down this one as a note. Ki the acceleration due to gravity, it doesn't depend upon the mass, okay, of the object. Either it is heavier or not. Always it will be 9.8 meter per second square for every mass of object. Okay, is it clear?
Mm-hmm.
Please note down this
Yeah.
one.
Okay.
Or any doubt?
No.
Now here one more point, threads of curiosity as per the equation 6.1. Okay, that the one this one we have discussed above. In activity 6.3, so doubling the force on the cart should have double the acceleration, right? You measured, but in reality you may have found increase to be little less than a factor of 2 similarly in activity 6.4. Okay, so when you double the mass of the card, the acceleration should have been halved, but you might have found a slightly different value. Okay, different value. Apart from measurement errors, the friction between the cart's wheel and the surface can lead to such difference. Okay,
Mm-hmm.
is it clear? Now here, one point is कि the more complete form of Newton's second law is expressed in term of momentum. The momentum of an object is defined as the product of its mass and velocity. Okay, you have to note down the momentum of an object. It can be defined as the product of the mass and velocity. The direction of the momentum is same as that of the velocity. Okay, please note down this one also. And here Newton's second law states that the rate of change of momentum of an object is proportional to the net force and take place in direction in which the net force acts. Okay. So Newton's second law expressed in this form is applied to situations even where the mass of the object is not constant. Okay. Is it clear? So you have to note down till here. Okay.
Uh-huh. Yeah.
This one from here the momentum. Okay, so this is also the important one, and I hope you understand the momentum, that it is the product of the mass and velocity. Okay, and it's Newton's second law state that ki change of the momentum of an object is proportional to the net force. Okay, and in the direction in which the net force act. Okay, so please note down it out.
No.
Okay. Now let's see here, as it said, कि Newton's second law of motion is considered to be a fundamental law of nature. Okay, many events around us can be explained on the basis of Newton's second law of motion. So in a game of cricket, you might have noticed that while catching a fast moving ball, the fielder gradually pulls their hand backward with the moving ball just after catching it, right? As you can see in the figure 6.8. Okay, so in doing so the time duration is increased during which the high velocity of the ball reduces to zero. Okay, and this reduces the magnitude of the acceleration of the ball as it slow down, thus requiring a smaller force to be applied by the fielder to stop the ball. Applying a smaller force to the moving ball also minimizes injury of the fielder. Okay, so
Okay.
for in example of second law of motion, you can write this ball कि while catching a cricket ball, we pushes our hand backwards with the moving ball just after catching it. Okay, so that it increase during with the high velocity of the ball reduces to zero. Okay, is it clear now?
Yeah.
Hmm. And here the next thing is कि bridging science and society. So for a similar reason, airbags are provided in vehicle. Okay, in the event of a collision and the vehicle coming to an abrupt halt, the airbag inflates quickly into a soft, compressible cushion instead of directly hitting the hard steering wheel or dashboard. The passenger's head and chest push into the bag, and the time over watching heating occurs increases. Similarly, acceleration means a reduced force exerted on the person, thereby lowering the risk of serious injuries, particularly when combined with the seat belt use. Have you ever so this one you can also write in the example of the Newton's second law of motion. Okay, inflated airbag in a
Okay.
vehicle. Okay, and the second thing is कि have you ever attempt cracking a fresh coconut in one go? It is brought down at a very high velocity to hit a hard surface, right? So when the coconut hit the ground, it stopped in a very short time. To change its velocity so quickly, the ground must exert a very large force on it. Okay, and that's why this large force break the shell of the coconut. Okay, so this one you can also write cracking a coconut in one go. Okay, now here there are some examples. So these examples are the question you have to try as a homework. Okay, is it clear?
Okay.
And if there will be any doubt, we will discuss it in the next class. Otherwise, we will start with the next one. Okay,
Okay.
Newton's third law of motion. Okay, is it clear?
Okay. So we'll do it right now or next class?
Newton's third law of motion.
Yeah, we'll do it next class or this class.
Next one. Okay.
Okay.
Yes, yes. So after this, we have to do the Newton's law of motion, and this one we will do in the next one.